Hello, and welcome to a video for grade 12 physics on Hooke's law. Hooke's law explains how springs and forces relate to each other. If I have a spring and I stretch it a certain distance, how much force does it exert? Hooke's law is very accurate as long as we don't stretch a spring past its springiness point, past its breaking point. Once you pass a certain point, it no longer follows Hooke's law because it is deforming in a different way. So let's take a look at our example here. The first thing that we need to know is that Hooke's law has a formula where the force of the spring is the spring constant K times X, which is the distance that the spring is stretched. This formula is in your formula sheet, and there is some other resources that can help you understand this. But this is the stretch, the X is the stretch of the spring from its resting point, and K is the spring constant. And the units for K are newtons per meter. Okay, so there is our formula. This is the Hooke's law formula. And that we're going to be using a fair amount. It is on your formula sheet. So Hooke's law, if I look at this, what I get is I say, here's my mass. I've got a mass hanging vertically from a spring with a spring constant K. Determine how far the string stretches. That's our X value there. We do have a mass here as well, which is important. Now, if I look at this object here, if I were to draw my forces into this, you may notice that there is a force due to gravity pulling it down, and holding it up against gravity is the force due to the spring. So looking at these, I can tell that my force due to gravity is going to be the same as my force due to the spring. They're just going to be in opposite directions. Gravity is pulling me down, so that we'll say is negative here. So let's figure out my force due to gravity. That one I already know is mass times gravity. So my force due to gravity is going to be the 1.8 kilograms times 9.81 for gravity on Earth. That then works out to negative 9.81, negative 17.658 newtons. There's my force due to gravity. Negative because it is down. Looking at the spring force now, there's my Hooke's law. And using that, I know that these are going to be the same, but just opposite signs. So I can go 17.658 equals my spring constant of 146 newtons per meter times the stretch. In this case, we can do the algebra, and the stretch works out to 0.12 meters or 12 centimeters. So there we go. There is the distance that this spring stretches. Okay? So this is a fairly common question, something similar to this. We're looking for the stretch of the spring, or maybe the force it exerts or something like that. In this case, we are using Hooke's law, which is something that you should be familiar with. This will show up quite frequently. Have a great day.